All right, y'all, it's time for another book review. So I really enjoyed making the last one about stolen focus, about how all the different media companies, tech companies are trying to steal away and profit off of our attention. And decided to go for a little bit more of a lighthearted book in subject matter, I suppose, in a fashion. So this is Extraterrestrial by Avi Loeb. He is the director, the head of the Harvard astronomy program. He's like the top dog in terms of Harvard astronomy. And it seems like he's gained quite a bit of notoriety over the last few years for some of his public speaking. And well, I suppose the books that he writes. And I had picked this one up long ago when I was in Maine a couple years ago. I'm really glad that I finally found a way to get off my shelf and pick it up to read. So a little bit of background on me, I suppose, to start is that I've always really been fascinated by science, and especially space. When the James Webb Telescope got launched a couple years ago, I was so excited. Like, I was so passionate about the new possibilities that such a telescope could discover new things about our universe that we're learning, and also the idea that it can look further back in time, since light takes a long time to travel long distances. If the James Webb Telescope can read information that has traveled farther away, then effectively travel from farther away, it effectively means that we can look further back in time, closer to our universe's beginning. So I've always been really super interested in science and especially space, which is why I ended up picking up this book as the next read. Again, with nonfiction, maybe get to fiction at some point. So anyways, that's enough about me. So the book, let's do another quick summary so can kind of get on the same page about what the subject matter is if you've already read it, or if you haven't read it, to provide context for my thoughts and feelings about reading it. So the book is centered around the phenomenon that occurred in 2017 that was observed, the phenomenon that was observed in 2017 called the ʻOumuamua object. And I'm a film man, I'm a filmmaker. This is what I do. So if I mess up any of the science, or my interpretation of it, and you know better, please correct me. But this is how I interpreted the science of what was going on. So essentially, ʻOumuamua was the first object that we've ever observed that has originated outside of our own solar system. So up to this point, that has entered our solar system. Of course, we've observed stars from millions and billions of light years away. This is the first object that is been from outside of our solar system that entered our solar system. And essentially what it did was that it came in, went around the sun, and then left. Doesn't sound very exciting, right? But the initial theories of what it was is that it could be a comet, right? Like it could be a comet, and there was just a lot of irregularities about this object. The specific one is that it deviated from its course. If scientists were, they did, but if you were to redo the math on it, if you were to predict the trajectory and the speed of this object based on just the slingshot it got around from the sun, then the actual path it took was different. And often that can be chalked up to and described as like a comet that is outgassing. So, you know, comets are made of rock and ice. As it heats up, the water evaporates and it propels the comet forward, which would be a reasonable explanation for why Oumuamua deviated from its predicted course. However, no visible outgassing was observed. So how could it have deviated if we were not able to record outgassing from typical comets? Additionally, the speed at which it left was matched what, I don't know the exact numbers, but essentially, if it were to be propelled by the sun, by sunlight, like it was being pushed by the sunlight, the course, the trajectory, the deviation it took lines up with the science behind how sunlight could push such an object. Right now, it seems, or at least at the time of the writing of this book, the scientific consensus is that it's a really, really, really rare rock. We didn't get a chance to take like up close pictures of it. So based on how it rotated and reflected from the sun, how it was moving, all the different ways that scientists and astronomers are able to identify objects in our night sky, based on, you know, all those unique characteristics, it was just a really, really rare rock. And the kind of conservative acceptance is that it's a long cigar-shaped object. But the author of the book, Avi, also has proposed that it could have been a light sail. So the idea of a light sail, which I kind of alluded to earlier, is that it's a very long and thin piece of a spacecraft, and essentially it can be propelled with light or radiation or whatever the sun emits. Kind of like how our sea ships get propelled by the wind if they're using a sail. But instead of wind, it would be, you know, the sun or light. And we didn't build it if that's the case. Basically how it was reflecting light and rotating was a little bit odd. And some of those anomalies for Oumuamua could lead us to believe that it could be shaped very wide and thin, like a light sail. And then the next assumption from that is that if it's a light sail, well, who built it? And the obvious answer is that we didn't build it, which would open the door to one of life's greatest mysteries of, are we alone in the universe, right? And so pretty much that's how the book is like set up from the beginning, right? This is a 1 in a trillion rock if it is like an odd shaped comet or whatever, in order for it to deviate, in order for it to reflect light like it did. But it could also be a piece of space junk. Like perhaps it was a spacecraft sent a really long time ago and we just happened to run into it. Or like something like a space buoy. Because another one of the anomalies of Oumuamua is that in a cosmic sense, in terms of the universe, it was not moving. Obviously it was moving. All cosmic objects are moving, but I don't remember the term. It was essentially, if you average out the velocity of all cosmic bodies in the universe, then there's like some relative to everything else, some objects relative to everything else aren't moving. And Oumuamua was one of those, that it was at like cosmic rest or whatever it was called, which obviously suggests that it could be like a non-functional light sail or like a buoy, like, you know, how we place buoys in the ocean. They're not supposed to move. They're supposed to be like wayfinding for explorers, navigators. So it could have been one of those. And so the rest of the book is basically talking about and trying to debate the idea of scientific conservatism. Essentially, poking and prodding at some of the most senior experts in their fields and how they tend to be more conservative as they get older. And that there's an incentive for also young scientists coming out of college doing doctoral work or postdoc work to fall into subjects that I guess maybe more attractive. Whatever that gets, whatever's gonna get the most funding that is popular at the time, because in order to do your work, you have to convince other people to invest or, file for grants and be granted that money. And for a really long time, the idea of like being a astroarchaeologist, as Avi puts it, looking for life or signs of previous life in the universe was laughed at. It wasn't a serious point of study. And so like pushing against that conservatism of there's a very real tangible value to looking for these types of things. There's a chapter in the book about how it's profoundly arrogant for us as a society to say that we're the only ones and that we're so unique. In the vast expanses of the universe, how arrogant it would be to say that we're the only ones to have ever existed and we're so smart and on top of things. The universe has existed for billions and billions of years. So civilizations could have cropped up and died off and we would have never noticed. I mean, our human civilization is so young in terms of being technologically advanced. We've only been really seriously studying the night sky and studying astronomy for 500-600 years at best. We've been looking at the stars for a long time, but it's such a tiny span of time compared to the whole scale, the timeline of the universe. So it's quite a bit arrogant for us to fall into the assumption and fall into the comfort of we're alone when, as the author points out, that if we are ever confronted with hard evidence that we are not alone and we are not the only life to exist, it would profoundly change how our societies look. It would, textbooks would need to be rewritten, philosophy would need to be rewritten and explored. We would all have, it would be quite a culture shock. I suppose that's not the correct use of that. We're more of a societal shock, and it could have a unifying effect as well. I mean, we realize that, wait, hold on, we're not alone out there. Maybe we should find a way to work together more. Adding to that, it's pretty unlikely that we're the only ones. Avi talks about how for basically all of our existence, we've always, on average, looking at history, we tend to focus in short-term rewards and I guess progress, right? We're not looking long-term. Generally, most people aren't thinking of what planet, how society, how humans are going to be and be living 3 generations from now, or how we can survive as a species since we've invented tools to annihilate ourselves. there's a theory, I suppose it might be a theory, is that there's this great filter that as technologically advanced species and life forms develop and learn more about physics and how the universe works, develops their technology, as they reach the point of being able to achieve interstellar travel, to expand, they also invent and discover ways of annihilating themselves. And the great filter idea is that before species can effectively colonize or spread out beyond whatever home planet they spawned on, that they've also invented the tools to destroy themselves. And you can see that we already have a bunch of tools to destroy ourselves, right? Like nuclear weapons are an obvious one. We've already used them. We've already come very, very close to starting a nuclear Armageddon. In the Cuban Missile Crisis, there was a nuclear submarine. This is not in the book, but there was a nuclear submarine where it got word that like an attack had started, right? And 3 officers needed to give the go-ahead in order to launch their own nuclear missiles, which would have cascaded into nuclear war between the US and the USSR. And one of those captains or officials decided not to launch. The other 2 did. One man, and unfortunately I don't remember his name right now, stopped this world from ending for caution, reason, whatever his motivation was. It ended up being a false positive. So whatever sensors were going off were not indicating an actual strike. And this one Russian submarine official saved the human race. So we've come really close to nuclear weapons, but there's so many other ways that civilizations can destroy themselves. Perhaps climate change. It's happening right now, whether you fill your head with cotton or stick your head in the sand. We are warming up our planet, and if that continues, then it could be catastrophic for everyone, even in the next 100 years. And we're already seeing that. 2 massive hurricanes hit the United States in 2024. Scientists have been saying for years that if climate change is not reversed, then severe and catastrophic weather events will continue to get more frequent and more disastrous. So climate change is another one, but also microplastics are found everywhere on this planet, at the top of mountains, at the bottom of the ocean. And we don't even know the full long-term effects of having and ingesting these microplastics in our bodies, in our blood. It could be, pathological. It could be the overuse of antibiotics. We create a super tough bacteria that kills us all. There's so many numerous ways for a technologically advanced civilization to design and invent the tools to destroy itself before it reaches the stars. And because of the great filter theory, if we look out into our universe, we could find remnants of other civilizations or technology that could advance us, allow us to take a great leap forward in our own advancement. So I think the book uses, like Avi uses ʻOumuamua as a way of creating a pitch for unity, to try to convince people to think more collectively, looking out for other people around us, less so than as individuals, and also for the science community to maintain or spark a little bit more childhood wonder. You know, he uses the idea of kids like, you know, they throw ideas out all the time. It's no hold bar. It's only when adults get in the room that have been shut down for, you know, their fun ideas, outlandish, that don't fit the norm, that they've receded into their turtle shell. It's only when adults like that come in the room that true creativity and inspiration gets stifled. And that's like, you know, he's arguing that, you know, the science, we should leave room for radical ideas. And of course, everyone always references Galileo. He proposed that, wait a second, the Earth is not the center of the universe. We orbit the sun. The sun is the center of our solar system. It's not the other way around. And the man was imprisoned and died in prison for his idea. And it was blasphemous, but of course it's self-evident at this point, you know, some 500 years later, yeah, obviously we orbit the sun. And the sun, it doesn't just stand still, it orbits in our galaxy. Like, we're not the center of our universe, except in one technical, physical sense, and how the universe is expanding, and technically any point of matter in the universe is the center of the universe. But the point is that it's arrogant to think that everything revolves around us. So that's kind of the argument that he made. And for my own personal takeaways, like, it was really, he writes in a certain way that is accessible, right? I haven't heard him talk about any of these things, but I have no doubt that like any speeches or any talks or interviews that he does would be really captivating for a general audience. He approaches it with a lot of humility. He approaches science with a lot of humility. Just because he's the head of the astronomy department at Harvard doesn't mean that he is too proud or egotistical to teach young people and also non-scientists. That was another part of the book, is that you know, a lot of people in science want to shield the public from all the messiness of science. You know, a lot of times when people are trying to answer big questions, they mess it up a bunch of times. They say that, you know, I fucking hate Thomas Edison, but like, you know, he tried to invent the light bulb 100 times, but only got it right at the last one. You know, science is messy, you make mistakes until you get it right. And in general, there's like this attitude that we should only come to the public and talk about the things that are happening in science when it's a certainty. There's no, like, you know, there's no question about it. But Avi, I think, correctly points out that if scientists do that, then what's happening right now is that there's a general distrust of scientists because, you know, it's all in this mysticism. You know, scientists a lot of times are looked on as wizards or witches that are, you know, spinning their webs. You don't know what they're doing. And he argues that more transparency into the scientific process would actually build more confidence in the scientific method and also the scientific community when they do have those big breakthroughs. And the general public would be more not susceptible, more open to you know, taking what they're saying and trying to apply it in a meaningful way. Where was I going with my own personal takeaways? Got a little distracted about the science and accessibility thing. I will say that about a third or halfway through the book, I decided to watch Interstellar again. And that is such an incredible movie. Something about how, you know, relativity is used as a plot device, that, you know, the main antagonist of Interstellar is time. is so cool. I don't think there's a lot of other movies that have achieved that, but also made it so relatable. It's anchored in this father-daughter relationship, and one of the main themes is love. It's like bananas that you have a movie that is so dense with science and physics and astronomy, but it's also so relatable. It's such an incredible movie, and it's very moving. When they go down to Miller's planet, it's full of water. It has experiencing a bunch of gravity. It's really close to Gargantua, the big black hole, and they lose 20 years. It's a significant blow to all the characters because they come back and all the people they left on Earth are 20 years older, and for them it was a few hours. Incredible movie. I'm a huge dork for, I guess relativity, and also quantum physics as well. There was actually a time in my undergrad for an English 201 class, the second English class that's required for a major at my university. I did a paper on quantum physics and relativity, and how they are both great theories, but they don't work together very well. What explains the physical laws that affect massive objects in the universe don't well apply to the things that are the tiniest in our universe. And that question and that challenge has been something that physicists have been working on for a long time. And I went to the library and read a few books on the matter, the subject matter, and it was just so much fun. And in fact, this book, even though my discipline is not science, is not physics or astronomy, it makes me really intrigued to maybe start pulling a little more academic sources or start to dive a little deeper, so I can just kind of self-direct my own research. I just kind of miss being a student, I suppose. I like learning a lot. But I think the biggest takeaway from Extraterrestrial is that we all, as a planet, we in society, we all in our own ways are trying to find meaning. We're trying to answer the question of what's the meaning of life and what's the meaning of our life. And I think the more you study astronomy and physics and understand our universe, the more inclined you are to be humble about your own existence. Just thinking about the time scale of the universe. We're so infinitesimally small portion of the time scale of the universe. We're one among billions on this planet in terms of people, but we're one among trillions when it comes to planets in the universe. I think that the more you research into it, the more inclined people will be to, the more you research this physics and astronomy, the more inclined people will be to be more compassionate, empathetic for each other. We only have, right now, we only have this one Earth. And everyone has a different idea about how we should live. And sometimes, and often, we have ideas about how other people should live. And I think that making that more accessible, more of this information accessible, will help more folks get involved in this type of subject matter. I'm not a scientist, but I was able to read this book and understand everything that he was talking about because he made it relatable in a human sense. And I think he did a pretty good job of convincing any reader of his different arguments. I'm not sure if I have too many other thoughts or takeaways from it, other than like it sure is relevant right now. Right now, as recording, the New Jersey drones are a big part of the news. These light orbs that are probably drones are showing up all over the place, and the U.S. government is, or at least some officials in the government over the last few years have began serious discussions about UAPs. It kind of feels like we're getting close to a point where we might find evidence of other life somewhere. And ʻOumuamua is one of those opportunities that we kind of missed, because everything that observed ʻOumuamua, at least initially, was completely accidental. There was a few telescopes or satellites, again I don't remember, that was trying to observe the sun and accidentally caught ʻOumuamua going around the sun. And most of our different installations didn't catch up to it until it was headed out of our solar system. So we missed the opportunity to get more data on what the heck it was. And that's kind of how Avi ends the book, is that, imagine if in, 1969 or whatever it was when we were going to the moon, that we discovered evidence of life on the moon. And we took this area of study, as he calls it, astroarchaeology, very seriously. We invested it, we prioritized finding more about our universe, and come again to 2017, we were able to identify ʻOumuamua before it even entered the solar system, and we sent out a probe to photograph it close up. And he talks about all these alternate realities, that if things had been a little different, how far along would we be in these areas of study? Another example was one of the initial Mars rovers that was sent out. To detect on whether life existed. And essentially the way it did it was it had like a device that like created a enclosed environment with Mars soil, and gave the soil like nutrients, like food that life would consume and create heat and metabolize it. And the rover had a device that would detect radiation. I think it was like to detect whether it was being metabolized. And essentially the rover was like, yo, something's happening with this radiation. And then they basically sterilized the soil to make sure that there was no life, and then there was no radiation. So it was marked as a false positive, and subsequent Mars rovers hasn't had a device like that to look for health, or to look for life in that manner. Our current rovers have other devices. I think that they're looking for more of like an elemental evidence, like water, or looking at the different rocks. I'm not super familiar, but again, he posits that imagine if we had continued to look for life in that manner, or instead of writing it off as a false positive, digging a little deeper to confirm what the data was saying. And for those that, we have a lot of terrestrial problems. If you're involved in politics or social science or anything, you know that we have some problems that face us right here And, you know, for those people, they would argue, why are we looking elsewhere on the planet? Why are we looking elsewhere when we have very real problems, when we should spend the resources on those very real problems? And it's, at face value, it has merit, right? Like, why would we spend resources, time, money into sending things outside of the planet when we could focus more about figuring our own shit out on our own planet? But if this book has taught me anything, it's another argument to that. And that is, if we invest in our resources to find out if we're alone, and take that very seriously, and be open to the possibility that we could discover evidence of previous life or current life outside of our own planet, then it could fundamentally change our own societies and how we think about ourselves. And it could, you know, optimistically make us more inclined to work together as a collective instead of I have mine, fuck off kind of mentality that we tend to see. So I like this book. I'm gonna leave my mind open to more of Avi's work, his own speeches. I'd love to hear him talk about these things instead of reading his words, just to kind of get like some personality behind it, to hear his passion for this and also witness his humility. And and I'm also open to reading more of his books. I think the next one I'm gonna do is gonna be more self-help, more introspective, which I guess sounds a little hypocritical when I just started talking about, you know, working as a collective. But one piece of self-philosophy that I hold is that you can't help others if you're not your best self. If you're dealing with your own shit, you don't have the capacity to help other people to the greatest degree that you can. And as I discussed in the last video, I've got a lot of shit that I'm still working out. So I'm gonna close in. I'm gonna shrink my universe for a little bit in this next book, and perhaps I'll see you in the next book review. So I'd recommend Extraterrestrial, Avi Loeb. It's not very long. It's less than 200 pages, and maybe it'll inspire you to watch Interstellar again, or Arrival, or 2001: A Space Odyssey, whatever your favorite science fiction, science-based movie is. It's all nerdy shit, and I'm here for it. Fiction or non-fiction, in terms of science and space and, you know, the Star Wars. So anyways, I'd recommend it. Check it out, and thanks for listening. If you've stuck around, if you have any thoughts about this book, if you've read it, or if you have anything to discuss in what I've talked about, feel free to leave in the comments down below. Until then, I'll see you in the next book review.